Hi everyone. This series is for the developers who don't just want their code to work, but want to understand why it works.
That's a tough question.
If you are a .NET developer or an aspiring architect and you are comfortable with basic C# and APIs, then you are exactly in the right place.
Yes! Bravo!
In this series, we are going to build a real microservices system step by step. We'll start simple and then gradually add Docker, database, caching, messaging, security, and an API gateway without breaking what we have already built. Everything lives in one GitHub repository, so you don't just learn features, you learn how the real systems evolve over time. With that context in mind, let's start with the fundamentals and build our first microservice.
I heard that. Let's do it!
Welcome to episode 1 of our .NET Microservices series. Today we are going to build our first microservice from scratch using ASP.NET Core. We'll build a clean and simple library API that manages video metadata. Our focus in today's episode would be on structure, clarity, and real-world practices. There is no database, no Docker, and no authentication in this episode. We are intentionally keeping things simple and focus only on the fundamentals today.
Oh, okay.
Before we write any code, let's align on what we are building. A microservice is a small focused service. It has its own business logic, it has its own data, and it can be developed and deployed independently. In this series, our microservice will manage video data. That means we'll support creating, reading, updating, and deleting videos. Whenever we talk about microservices, an important question comes to our mind, and that is, who is allowed to change the data? And that is why you might wonder why I am bringing up the topic of admin so early in this discussion. In many systems, teams create separate admin services, which often results in duplicated logic and broken service boundaries. So let me be very clear here. Admin is a role, and it is not a microservice. The library microservice owns the video data regardless of who is calling it. Admin, user, or maybe another service. We'll handle the authorization later, but the business logic should stay here in this microservice.
You're exactly right, and you get a point.
Now that this boundary is clear, let's jump into the code and build our service. Wait. Before we test the editor, I want to align on how we are thinking about this service. Because in microservices, the architecture decisions matter more than the code choices. At a high level, this library service has exactly one responsibility. It manages video metadata. And that's it. Not user, not permissions, not recommendations, just the videos. If something doesn't directly support that responsibility, then it doesn't belong in this service.
Yes! That's awesome!
Now, in this episode, we are deliberately keeping storage in memory. And that is not because databases are hard, it's because architecture should evolve step by step. Right now, our goal is to answer a simple question. Can we design a service with clear boundaries, clear ownership, and a predictable behavior? If we can do that with in-memory data, we can absolutely do that with a database later. So here is the structure we're aiming for. We'll have a controller that handles HTTP request. We'll have a model that represents video metadata. We'll have a repository that hides how data is stored. Even though the data would be stored in memory, we'll still treat it like a real persistent layer because that abstraction is what allows the service to grow in future without modifying everything. This is an important idea, so let me say it very clearly here. We always design by keeping change in mind, even when the implementation is extremely simple. Because if you hardwire the decisions too early, then microservices become fragile instead of flexible. But if you respect the boundaries from day one, then each future enhancement would be smaller and safer. With that mental model in place, we are ready to start coding. Let's create the library API and put this architecture into practice. Alright, let's start turning our idea into code. I'm creating a new ASP.NET Core Web API. Nothing special, just the basic template. When you build microservices, your starting point should be simple. If the foundation is simple, everything you add later would be easier to manage.
Correct.
I will name this project Library API. LBR Library API. The name is important because it clearly tells us what the service is responsible for. This service owns a library domain, specifically the video metadata. Let's see what else we get as a default template. So I'm choosing .NET 10 long-term support because that is the one installed in my system. If you have .NET 9 or .NET 8 installed in the system, you can choose either of those. I don't need HTTPS, enable Open API support, yes, use controller. So it gives us a default controller. It would be Weather API controller, I believe. Let's create it. So we got default controller and a default model as well. We don't need them, so let's delete them. Here is a simple rule to remember. If something does not support what the service does, it does not belong in the service. Now let's add the basic folder structure here. Controllers folder is already there. So we are missing with the models and the repositories folder. So let's create those. New folder, models, repositories. Even though this is a small service, this structure keeps things very clear. So with this basic setup ready, let's move on to defining what this service actually manages. Let's start with the domain model. In this model folder, I'm going to create a video class. This class represents video metadata. It does not handle video playback. It does not handle streaming. It only represents the data this service owns. So as of now, the video will have an ID. It would have a title, a description, and a duration. That's enough for this class. Remember, we are keeping things simple on purpose. For those who are not sure what the syntax is, this just means we are giving the property a default value. So instead of starting as null, it starts as an empty string. This helps us in avoiding null related issues later, especially when the model is very simple like this. It also makes the code easier to work with because we don't have to keep checking whether the value is null or not. For now, this is a small but helpful habit. We can always add proper validation later when the service grows and we actually need it. Next, we need a way to store these videos. We are not using databases yet, so we'll create an in-memory repository. Inside the repository folder, I'm adding a repository for videos. This repository is responsible for managing video data. Even though the data is stored in memory, we treat this like a real data store. The controller will not know how the data is stored. This will only know which repository to call. This separation is important. inside the repository, we'll keep simple collection of video like this. And we'll add basic functions to get all videos, get video by ID, add new video, update a video, and delete a video. These methods define what the service can do. We have not included the HTTP capabilities yet, because that we are going to add in the controller. From this point, I'm going to fast forward the video while I'm doing the typing job, so that you don't need to wait and see me typing. Don't worry, I will explain everything once I'm done with my coding. So I have added all the necessary functions for this class. We have getAll, which returns all the videos present in the list. GetById takes an ID as a parameter, input parameter, and then searches a video where the ID matches and then returns it. Add will add a new video to the list. Update will update the video if it finds. Delete will remove that video from our list. For those who are a bit curious to understand what is this new syntax, this has been introduced with C# 6.0, where this fat arrow separates the method signature and the method body, which executes and returns the value of the object. So this can be applied to any function which has a very simple statement like this, which returns an object or a value. We already created the in-memory repository class. Now I'm going to extract an interface from it. This doesn't really change how the code works. It just changes how the rest of the services depends on it. Instead of depending directly on this class, this concrete class, other parts of the code will depend on the interface. That means they only care about what methods are available, not how these methods are being implemented. Right now the implementation is in memory. Later we might switch to a database or something else. When that happens, the interface stays the same. This is a very simple step, but it gives a lot of flexibility going forward. So let's extract the interface and use that instead. For that, we have a shortcut, control dot. We call it I video repository. Let's keep it here. Library API. Done. So now we have the model and the repository class created. Now with the model and repository ready, we can expose this through an API. For that, we need to create a controller. Let's create the controller. Inside the controllers folder, I'm going to create videos controller. We can select MVC controller empty template, and then we can select API controller empty template. I will call it as videos controller. This controller enables the outside world to talk to our library service. The controller's job is very simple. It receives the request, calls the repository, and sends back the response. It does not have the business logic though. Next, I will inject the repository in our controller. We'll do it in the default constructor. Let's copy the name. This means the controller depends on behavior, not how the data is stored. Next, we'll add our endpoints. So we'll add get all, get by ID, post, put, delete. Looks familiar, right? And that is a good thing. Clear and predictable APIs are easier to maintain and easier to use. So let's implement all our methods. I'm using Visual Studio as my IDE, and that is why I was getting those intelligence. Visual Studio is quite feature rich. It offered me the intelligence, I happily accepted, and that is how I completed my entire code. But now let's understand what is written in this file. Starting from the first line, this is called route attribute. So this route attribute tells us what would be the URL that would be used to invoke this controller. So the URL would be API/controller. Here the controller name is videos, so the URL would be formed as API/videos like this. And the first get method is get all, which will return all the videos. Here we are calling the get all method of our repository, which is this one. Once we have all those videos, we are returning back an OK response. Now OK response is 200. If you wanted to know more about the various responses, HTTP responses, then we can directly go to the W3C schools to understand. I already opened the W3C schools page. You can search HTTP response codes, and it's probably the second link you will get. Here 200 OK, and the description says this request is OK. This is the standard response for successful HTTP request. So in .NET we can use this OK function, and you can hover the function name as well, and you can see it in the description, the status code 200 OK response. Next get method is our get by ID, but here we are supplying the ID as a parameter in the query string. So this will again call the get by ID function of our repository, which is this one, which will return me a video. It can also return null as well. So if we don't get any video for the supplied ID, we are returning not found, which would be 404. I think, yeah, it's 404. So let's see what is the description of 404 here. So 404 is not found, and it tells that the requested page could not be found but may be available again in future. So in summary, it tells us that currently the resource is not available, what we are searching for. But then if we get the video, we return back the video with OK response, which is 200, response code 200. Now the get methods are completed. Coming to the post method, which we normally use to create resources. So in the post body, we are sending a new video item. So new video item would be supplied to the add method of our repository, which is this one. We increment the ID and then we add the videos to our list and then return the video. Here, once we have the created video link, we are returning, I think, 201. Yes, 201. So this 201 response, let's understand what is 201. So all this 200 series is okay, means successful response, but then it has more variations, like 200 is okay, 201 especially means that the resource has been created. You can see the description, the resource has been fulfilled, the request has been fulfilled and the new resource is created. Coming to the next method, next is HTTP put. Again, this is a post request, but put is majorly used when we want to update something. So here we are taking the ID in the query string and the video in the post body. Here, if the ID, supplied ID and the video ID doesn't match, we respond back with a bad request, which is I think 400. Yeah, 400 bad request. So let's understand what is the description for this one. 400 is bad request, and that means the request cannot be fulfilled due to bad syntax. That means the client has supplied, or whoever is invoking this put method has supplied wrong arguments. This ID and the ID inside the video should match. Okay, if it matches, it calls the update method in our repository, which is this one. And if you see the body that of the function, we are retrieving the video first and then modify the items in the body of that video and then return true or false. So it returns a Boolean expression. So if we get true, that means the video has been edited. If we get false, that means the video is not updated. It's not edited, sorry, updated. My bad. Yeah. So here the result stores a Boolean value, true or false. If false, that means we could not find the video, and that is why we are returning not found, which is 404 again. That says that the resource we are searching for or looking for is not present currently. If the video has been updated successfully, then it sends a success response, but then this time it doesn't return okay. It is no content, which is 204. Let's understand what is 204. So 204 is no content. The request has been successfully processed, but is not returning any content. So the video has been updated, but then nothing has been returned. We can always return we can return the video as well. The next one is, or the last one is delete, which takes an ID in the query string, and we call the delete method in our repository, which is this one. It deletes the video from our list and returns a boolean expression, true or false. That means if the video has been removed, it will return true, or probably the video is not present, then also it will return false. So it's pretty simple. If we were able to delete the video, we'll return no content, which is 204. If we could not find the video, then we'll return 404. That means the resource we are searching for or we are targeting to delete is not present. Right now we are done with the coding part of our controller. It's almost ready to be tested. We are left with one more thing. We need to find a way to inject a concrete implementation for this interface whenever we'll hit a URL such as API/videos. And for that we need to use dependency injection. In .NET Core, we have built-in dependency injection that is normally written inside the program.cs. For injecting the dependency, we only need to add one line of code, and the intelligence perfectly tells me what needs to be done. I will explain this code. Let me remove the unnecessary codes which are making things complicated. So here we are trying to inject the object of in-memory video repository whenever any class is requesting a concrete implementation of iVideo repository. And the scope of this has been mentioned as singleton. There are two more scopes present in .NET Core. One is transient and second one is scoped. So transient, it tells the runtime environment that whenever the service would be requested, for example, a new URL is hit, right? Whenever this service is requested, it creates a new instance of in-memory video repository and pass it on to the controller. The scoped one is, it tells the runtime environment that create only one object per request. So in our case, both of them will work or behaves in a similar way, but slowly when the application will grow, you will very clearly understand the difference between scoped and transient. Singleton is like it stays throughout the application. So we close the application, the object would be destroyed, of course, but then as long as the application is running, the object will stay in the memory. And why we need it? It's because we are storing our objects or the videos in memory. So if we change it to transient or scoped, then let's say we are trying to fetch all the data, that would be, we are hitting this API/videos endpoint, that would be single HTTP request, and it will return the response. Once the response is written, then the subsequent request, let's say I want to create a video, and for that I will hit an endpoint something like API/videos, and it would be a post request. So that would be treated as a new request, and then it will create a new object of this class. The moment it will create a new object of this class, if you see inside the code, it creates a new list. So we'll not get the videos which are present in the memory. So that is a very short summary. However, I will create a dedicated video to explain the various scopes present in .NET Core. That's not part of our today's video agenda. So let's proceed with our plan. So now we have written the code for injecting the dependency. It should ideally work. Just to show you that this application is running, I will run it. And you can see this application has been started. The Castrol web server has hosted this application in port number 5279. Copy this one, go to browser, paste it. You will not see anything because we are not specifying the URLs correctly. So if we want to see all videos, so the URL should be API/videos. Currently we will not see any video because we have never created anything. So this is the URL. And it returns empty array, which is expected. In .NET Core, it also has this open API specifications. We can see the API specification here. In order to see the specification, the URL is service URL and then open API/v1.json. So this is the entire specification, which gives us the schema and the endpoints which are present in our service. If you want, you can download it and save it to understand how what is the schema for our application. But then we still are dealing with a challenge how to test our services. Before .NET Core 9, Swagger was automatically included in program.cs, so we see a nice UI whenever we run the application. But then after .NET 9, this has been removed, so we can anyway add Swagger in our program at any point of time. But then I wanted to show you something more interesting. So there is one more library called Scalar, which is currently very heavily used. So let's add that. We can add it through package manager, or we can add it through developer PowerShell as well. So through package manager, if we want to add, then we have to select Scalar, and ideally it should appear the first one. Yes, this is the Scalar ASP Netcore, and if you see, it has 12.2 million downloads already. So yeah, it is being used heavily. So let's download it and install in our project. It's .NET ASP Netcore 2.12.7. okay. As long as we do that, it should be having the dependency added. See, we have Scalar ASP Netcore 2.12.7 added. Now we don't have to do much. We just have to add one line: app.map Scalar API references, and that's it. We are done. Now this will give us a very nice UI if you hover on this one. So map, you can see the definition. It maps the Scalar API reference endpoint with the default endpoints, and it tells us how to open the UI. So let's do that. Run this application again. Let's close this one. Yes, it is started. Go back to the browser. Now here we have to write Scalar. And you see, it gives us all the information for our API. So the API is library API version 1. So how version 1? Version 1 is the default version. We can have different version as well. Okay, it has a very nice documentation. It tells everything about our API. It has all the endpoints listed already. So let's use the get. Of course, we'll not see anything. Click on test request and hit on the send button. It gives us 200 okay response, but then we don't have any object to display or any videos to display, which is okay. We'll create videos now. Go back. Let's create some videos. The nice thing is it gives us the schema or the body. We don't need to write it. We just have to modify the values. So let's say my first video and then sample. Next description, duration is, let's say 2 seconds. Hit send and the video is created. Let's create one more. My second video, sample description, let's say 2, and then this one is 6 seconds. Hit send. Okay, second video is created as well. Let's see whether we can list all the videos or not. Click on the get method, hit send. Yes, all the videos are listed here. So we have 2 videos created in our list. Let's try out the get method with the ID. Here we supply the ID. Let's see whether we can see it or not. Yes, it returns the correct result. I supplied the ID 2 and it gives me the second video which was stored with ID 2. Change it to ID 1, hit send. It gives me the first video. So it's working. Let's try to edit one video and let's say we'll edit the second video and then title is ID value is 2 and the title is edited title. Description is something nice about the video. This one I will change to 5 seconds and hit send. We are getting 204, no content, but then it is a success message. Again, click on get and here we'll see the updated details. Edited title, something nice about the video, and duration is 5 seconds. Let's try the delete method. Here we supply the ID. Let's say we'll delete the first one. Hit send. 204. Green color means success. And if we click on the get method, we'll see only one video present in our list. And if we delete the second one as well, then basically our list is empty and it will return us an empty string. Now let's commit the code to GitHub. This step is important because commits are not just backups. They mark important points in the project. Right now we have a clear service boundary, a working API structure, and a clean readable code, which makes it a perfect place to commit the changes to GitHub. I have already checked in the code in GitHub. I will paste this repository link in the description so that you can clone the repository and go through the code. From here on, every change will build on this so that if something breaks, we always know where we started. Let's recap what we built in this episode. We built our first microservice, a real one. It owns its data, it owns its business logic, and it runs independently. We kept things simple. No database, no Docker, no authentication. And that was a deliberate choice. Right now, the service works, but in real systems, this is not enough. In the next episode, we'll Dockerize this service. We'll package it so that it runs the same way everywhere without changing the code or breaking the service boundaries. Build it simple today so it can scale tomorrow.